welcome back to another separate video, and in this video we're going to talk about problems number 11 through 15 for the AMC 10A 2020. So this is problem number 11 over here, and it asks us, what is the median of the following list of 40 numbers? And our numbers are 1, 2, 3 all the way to 2020, and then 1 squared, 2 squared, 3 squared all the way to 2020 squared. So in order to find the median, what we have to do is find the middle term. But in this case, the number of terms we have is not exactly odd, meaning that there are going to be two middle terms. And if we have two middle terms, in order to find the median, we just need to find the average of them. So basically we need to find the 2020 first term and the 2020th term, and then take the average of those two. But obviously we can only find these two if our list is ordered. And in order to order our list, we need to find the greatest perfect square that is less than 2020. And that's, after a bit of playing around, that ends up happening to be 44 squared. So 44 squared is equal to 1936, meaning that all the numbers, all the perfect squares before 44 squared can come in between 1 and 2020. So our list is going to look something like 1 squared, 2, 3, 2 squared, 4, so on, all the way till 44 squared, and then 1936, and then continuing on all the way to 2020, and then after that we have 45 squared, then 46 squared, all the way to 2020 squared. So that all we need to do is just find the median in this list over here. So what we know is that we need to find what term number this is. So we know this is going to be the 1988 term, because we're adding in 44 numbers before 1936, 44 extra numbers before 1936. And basically this becomes a 1988 term. So now in order to find the 2020 term, we just have to add 40 to 1936. So the 2020 term is going to be equal to 1936 plus 40, which is equal to 1976. And the 2021st term is just 1 plus that, 1 plus 1976, which is equal to 1977. And the average of those two is 1976.5, which is our final answer for the median of this list over here. So this is problem number 12 over here. Triangle AMC is isosceles with AM is equal to AC, and MV and CU are perpendicular medians to each other. And MV is equal to CU, and they're both 12. So what is the area of triangle AMC? So we see here that triangle AMC is given, and what we want to do is try and relate the diagram to the description that we have been provided with over here. So we know that the distance from M to B is 12, and the distance from C to U is 12 as well. And we also know that medians MV and CU are perpendicular to each other. And when two medians intersect each other, they split the other median apart into pieces from a ratio 2:1. So we know that M to this center point P is going to be a value of 8, while P to B is going to be 4. And we also know that C to P is going to be 8, and U to P is going to be 4. And whenever I see two medians already drawn, I like to draw a third median. And with that third median, finding the area of the triangle becomes much more simpler, because the area of one of these small little triangles produced by all three medians intersecting is going to be 1/6 the total area. So basically what we need to do is just find the area of one of these triangles and then multiply by 6. And we can easily find the area of triangle UPM, because we know that since these two medians are perpendicular to each other, this triangle of UPM is a right triangle. And the area of this triangle, UPM is equal to 4 times 8 divided by 2, which is equal to 16. And the area of triangle AMC is equal to 6 times 16. So 6 times 16 is equal to 96, which is our final answer for this problem over here. So this is problem number 13 on the test. And this states that a frog sitting on the point 1, 2 begins a sequence of jumps where each jump is parallel to one of the coordinate axes and has a length of 1. And the direction of the jump, up, down, left, or right, is chosen independently at random. The sequence ends when the frog reaches the side of the square with coordinates 0, 0, 0, 4, 4, 0, and 4, 4. What is the probability that the sequence of jumps ends on a vertical side of the square? So the first thing to note is that we're using the coordinate axis, so the best thing to do would be to draw that out. And we know that all of our points are in the first quadrant, so we don't need to bother drawing the other quadrants out. So I'm going to draw like this, and then I'm going to label them 1, 2, 3, and 4. 1, 2, 3, and 4. So here is our box, and we know that our frog starts at 1, 2. And we can just draw a box around here signifying that our frog would end its journey if it ever reached one of these points. So we know that now we need to find out what is the probability that the sequence of jumps ends on a vertical side of the square. So meaning like here or over here on this side. And the way we can find that is just by trying each side and seeing which way the frog will end up. So we know that there's a 1/4 chance of it moving to the left, and then if it moves to the left, then it automatically ends the game, or ends the sequence. So 1/4 is part of our chance. And then we need to add up all the other probabilities that are possible. If it goes to the right, it's going to be the center where it can access every single point equally. So the probability of it ending on a horizontal axis is the same as ending on a vertical axis. So we can write that as a 1/4 chance of going right, and then a 1/2 chance of ending on the vertical axis. Now what if it goes up? Well, if it goes up, then it's similar to the central point in the fact that it has a 1/2 chance of ending on both the horizontal axis as well as the vertical axis. So we can see that there's a 1/4 chance of it doing that and then ending up on a horizontal or vertical axis. And then when it goes down, that's the same thing as if it were to go up, meaning that it could end on a vertical or a horizontal axis at the same probability. So it has a 1/4 chance of going down, and then a 1/2 chance of ending on a vertical axis. So if we just sum these all up, this would be 1/4 plus 3/8. And if we add that up again, that's going to be 5/8 as our final probability for this question over here. So this over here is problem number 14. And it asks us, real numbers x and y satisfy x plus y is equal to 4 and xy is equal to -2. So we're asked to find the value of x plus x cubed over y squared plus y cubed over x squared plus y. So clearly we're going to have to do some algebraic manipulation because these two identities, or basically values of x and y, do not exactly fit into here. We can't exactly plug them into here and expect to get an answer. So what I'm going to do is kind of try to group these together. So what I'm going to do is x plus y cubed over x squared plus x cubed over y squared plus y. And what I'm going to do now is get common denominators in all of them. And this becomes x cubed plus y cubed over x squared plus x cubed plus y cubed over y squared. And we can add these together by making common denominators. And by doing so, we get y squared times x cubed plus y cubed plus x squared times x cubed plus y cubed is divided by x squared y squared. And that is the same exact expression over here. And then we can factor out x cubed plus y cubed, leaving us with x squared plus y squared times x cubed plus y cubed divided by xy whole squared. And now we can use these two identities to help us find the final value of it by doing some more manipulation inside of here. So x squared plus y squared can be represented as So what we do here now is try to find each of these individually by using factoring or some other algebraic manipulation and then plug them back in to find the total value. So x squared plus y squared. X squared plus y squared. And x squared plus y squared is basically the same thing as x plus y whole squared minus 2xy. Because if you expand this out and then simplify, you end up with x squared plus y squared. So x plus y, as we remember, is 4. So that's going to be 4 squared, 16, minus 2 times x times y, which is negative 2. So this is going to be equal to 16 plus 4, which is equal to 20. So x squared plus y squared is equal to 20. And x cubed plus y cubed can be factored into x plus y times x squared minus xy plus plus y squared. And we can factor it out like that. So x plus y is equal to 4, as we know before. And then this over here is the same thing as x squared plus y squared minus xy. And as we know from before, x squared plus y squared is 20, and xy is equal to negative 2, meaning that over here it's going to be 4 times 22, which is equal to 88. So x cubed plus y cubed is 88, and xy is equal to negative 2, and if we square that, we get 4. Meaning that when we plug everything back in over here, it's going to be 20 times 88 divided by 4. And if we solve that, we get 440 as our final answer over here. This is problem number 15. A positive integer divisor of 12 factorial is chosen at random. The probability that the divisor chosen is a perfect square can be expressed as m divided by n, where m and n are relatively prime. So we're asked to find what m plus n is. So the first thing that I think about when I see the word divisor is the prime factorization. And given that our only number is 12 factorial, it would make sense to take the prime factorization of that. So 12 factorial, it can be represented as 2 to the power of 10 times 3 to the power of 5 times 5 squared times 7 times 11. So that is our prime factorization over there. And we can, some of the examples of perfect squares we can choose are something like 1, 2 squared, 3 squared, 5 squared, and maybe some combination of them. So something like 2 squared times 3 squared, which is 36, which as we know is a perfect square. Or maybe something like 2 squared times 5 squared, which is 2 squared times 5 squared, which is 100, which is also a perfect square. Or maybe just even a combination of them. So 2 squared times 3 squared times 5 squared, which is equal to 900. And as we know, that is a perfect square. And the list keeps going. We can choose a lot of different possibilities. And the way we can do that is by thinking of the number of possibilities we can choose for having 2 to the power of some exponent. So our possibilities are 2 to the power of 0, 2 squared, 2 to the power of 4th, 2 to the power of 6, 2 to the power of 8, and 2 to the power of 10. And then our possibilities for choosing from 3 to the power of some number. So we have 3 to the power of 0, 3 squared, and 3 to the power of 4. And from choosing from 5 to the power of something, we have 5 to the power of 0 and 5 squared. And for 7 and 11, these aren't exactly perfect squares, so we can basically choose just their powers of 0, which is just 1. So we realize that we have 6 possibilities over here, so 6 times our possibilities over here are 3 times the number of possibilities over here, which is simply just 2. And for here we have 7 and 11, which just gives us possibilities of 1 times 1. Meaning that our total possibilities of choosing a number, number that is a perfect square is 36. But we're not done here. We have to express this as a probability. So a probability is basically the number of favorable outcomes divided by the number of total outcomes. So the number of our favorable outcomes is 36, but we still need to find the total outcomes. And in order to find the total number of divisors of 12 factorial, we can actually use a fairly simple formula. We just need to take each power over here, add 1 to that, and then multiply it by all the other powers. So if I have 2 to the power of some number 10, I can do 11, which is 10 plus 1, times, and for 5 I can do 6 because it's 5 plus 1, times 2 plus 1, which is 3, times 1 plus 1, which is 2, times 11 to the power of 1 plus 1, which is again 2. So let's just plug this in over here. 11 times 6 times 3 times 2 times 2. So this is basically our probability over here. And when we simplify this, well, we can cancel out this over here, and we can cancel this to get a total of 1 over 22 as a probability, but we're still not done there. We need to find m plus n, basically the numerator plus the denominator. And in that case, 1 plus 22 is 23, which is our final answer over here.